Today we're going to be looking at the third point in the series of 3 videos, Understanding Area for Advanced Minds. Now I say advanced minds, but really everyone should understand this because it's really what area is. If you don't understand this video or this lesson, then basically all you're doing is multiplying length times width and not understanding how area works and how it relates to multiplication. Let's quickly review the big idea of area. The area of an object is a two-dimensional attribute, and those two dimensions are length and width. You should also remember that I've brought up the fact that area and multiplication go hand in hand. In younger grades, when students have difficulty remembering multiplication, we tell them to draw an array. An array is basically a circle model. So you have 16 circles going across, and you have 7 going down. So you draw all these circles to find the answer for any question. Now, usually the number is not as big as 16. You would draw an array for something like 7 times 6 or 7 times 8 or a multiplication fact that you don't know. The strategy is not very efficient, and you got to keep drawing circles, and you have to line them up correctly. It's very easy to make a mistake, but if you count all the circles and if you do it correctly, you will get an answer to what 16 times 7 is. Now, moving away from circles and looking at a strategy that is more efficient, we can use an open array or an area model. And this still has circles, but notice where I put the dotted lines. The dotted lines are here, right? And you can see them. There's another dotted line here and here. But notice where they're placed. So the dotted line is placed where there's 5 circles across. So in this section here, we know that there's 7 times 5 circles. Okay? I don't always need a whole number. I know there's 7 times 5 circles in this little section here. Okay? Now, 5 is a friendly number, and I always pick 5, and you can repeat 5 here because I put the dotted line where 5 is, and I put the dotted line over here where there's 5 as well. And then this one, this row of circles here is 7 times 1. Now, according to the distributive property, I can add these products. You know, I know that's 35. You know, there's 35. There's another 35, and there's 7. I would add those products, and I would get the answer for the original question of 7 times 16. This open array still has the circles, obviously, but this time I chose another friendly number. So if you count the circles from here to the first dotted line, there's 10. So how many circles are in this section? If you said that there are 7 times 10 circles, then you're right. So 10 is a friendly number because anybody can multiply a number by 10. In this section, you know, we can count the circles again, and we know that there's 5, so that we can say that there's 7 times 5 circles. And then finally we have 7 times 1. Okay, and again, I don't always need an answer, but if we add the products, we will get the answer to the original question, that is 7 times 16. So, you know, there's 70 here, there's 105, and then there's 112. So 7 times 16 is 112. So that's a mental strategy to help you get an answer for a question you originally probably wouldn't know because it's too large. Moving on, here's an open array, and there is no circles this time. I want you to think of this as maybe your bedroom, and I'll explain why a little bit later. So think of this as your bedroom or one room in your house. Now, I can make an open array myself, and I can cut it up, and I can say, all right, I'm looking always for my friendly numbers. So there's my dotted line. Now, my friendly number, I'm going to pick the larger one, is 8 times 10. So that means in this section, when we think of area, there is 8 times 10 circles in this section. And you probably already know what 8 times 10 is. Now, the other thing we have to consider is that we have to think about how many circles are here. Well, if there's 10 in this section, right, so we did 8 times 10, and I could even write a 10 here, that means that there's 4 left over because there's 14 circles going from here to here. So from here to here there's 10, and from here to here is 4. So the next equation, so in this section there's 8 times 10. So imagine that there's 10 circles from here to here. Well, if there are 10 circles from here to here, I would know that there are 4 circles left over because there's 4 circles from here to here, but we don't have to draw the circles. And so the equation that goes into this space would be 8 times 4. So if we think of trying to come up with the area for this room, then the area is basically the products of these two equations added together. So I know that 8 times 10 is 80. And I know that 8 times 4 is 32. So if I add them, then the area is 112 units square. I can also say that there are that the answer for 8 times 14 is 112, right? So I hope that you understand that. So that's the area, but it's also the answer for 14 times 8. Now the fun begins. This open array is really an area model because there's going to be a whole lot of equations. Now, in the first example, I said, okay, think of that as your bedroom or one room. This time I want you to think of this as your whole upstairs. So if you think of your upstairs, there's probably 3 bedrooms, a washroom, right? So think of this as trying to find the area of a whole floor instead of just one room. Now the first thing I'm going to do is I'm going to break these numbers up into my friendly numbers. So 24, I'm going to get rid of that because that's such a large number, and I'm going to say, okay, there's 10. Okay, and then there's going to be another 10, and then there's going to be a 4. Okay, so I use my friendly numbers 10, 10, and 4. Now the 18, I'm going to get rid of that too, and I'm going to say, okay, there's 10 here, and there's 8 there. Okay, and I'm going to make my dotted line. So 10 will be a little bit larger, so let's make my sections. There's one section there, right? And I can do 10 over here, and I can do 10 over here. And just like that, I've made my sections for the open. Now let's actually think of the equations that are in. Basically, all you have to do is bring these two numbers together, right? So in this section here, I would say that there's 8 times 10. And how did I get those numbers? Well, very simply, I took these two numbers and I put them together, and I got 8 times 10. This section here, okay, I'm just going to put these two numbers together, and it's going to be 10 times 10. Right? Can you think about what would go here and here? If you said that it would be another 8 times 10, then you would be correct because we're just basically bringing these numbers together. Okay? And here there would be, again, another 10 times 10. Right? Here there would be 8 times 4. And this last one here, I'll give you a minute to think about it. Here are all the equations. Now, like I said before, if you add all of these equations, their products, you would come up with the answer to the original question, 18 times 24. So I could say that 8 times 10 we know is 80. 8 times 10 we also know is 80. 8 times 4 is 32. 10 times 10 is 100. 10 times 10 is another 100, right? 10 times 4 is 40. Now I'm going to ask somebody in the audience now to kind of put all those numbers in the calculator. I'll press pause on the video and someone can tell me the answer. But before we do that, there's other things we could think about. That if this was the second floor of your house, that this room here would be 8 by 10 units. This room here would be 8 by 10 units. Right? This room here maybe would be the bathroom, and that's maybe a little bit smaller, so that would be 8 times 4. Maybe this is the master bedroom, so it's a little bit larger. So area models are you can think about it as maybe all one room if it's a large room, or you can think about it as all rooms put together. Let's conclude our lesson by looking at distributive property. Distributive property was brought up already, and basically it means that you can take a larger equation like 19 times 6 and break it up into smaller equations to come up with the product. It is definitely a mental strategy. So let's try to solve this equation. So 19 times 6, if I'm going to break it up into two equations, the first one will be 10 times 6, and the next one would be 9 times 6. Okay, so 10 times 6 is 60, 9 times 6 is 54, and if I add these two together, I get 114. So 19 times 6 is equal to 114. So here's the distributive property once again. But we can, in this lesson, we were looking at open arrays and area models, and just to do one more to show us that we get the same answer, the first thing I'm going to do is I'm going to break 19 up into my friendly numbers. So I'm going to break 19 into 10 and 9. I could go 10, 5, and 4, but I'll do 10 and 9. So here's this area here would represent 6 times 10, and this area here would represent 6 times 9. So you could see here that I get the same equations that I did over here. Okay, it doesn't matter that the numbers are flipped. So once I add these products, I would get the original answer for 19 times 6. So let's review what we've done, and this has been a very important lesson, bringing multiplication and area together. First, we could say that using an open array helps us to solve larger questions without drawing all those circles. You can draw all those circles, but it's inefficient, easy to make mistakes. When we do 2-digit by 2-digit multiplication, we create an open array that's called an area model, and think of that as the second floor in your house. The distributive property was what we just did in the last slide. It breaks larger questions into smaller equations. It works all the time, and it could take the place of an area model, but sometimes you want to use an area model to help demonstrate your math and show how well you understand your math.